Okay, guys, so last time we talked a little bit about using Euler's method, and today we're going to try this thing out. We started with a function dy by dx is equal to 3 over x. Okay, and if you recall, and even if we were in class, this is a formula I would absolutely provide to you where you would have the y new, remember, is equal to y old plus f of x old y old times delta x. Make sure I'm still in frame there. I sure am. Okay. So we're going to make up a table, and it's going to have an x old and a y old in it. Okay, it's going to have the f of x in it. We're going to call that h, right? And we're going to have our h in there. And pretty much we're just going to set this thing out, so we're going to try to make this as easy as possible to just kind of move forward in the table until we get to our y new, which we're going to replace in here, and then we're going to repeat the process over and over and over until we get to the right spot. Now, your book likes setting h to be 0.1. Remember, this is your change in x, okay? By the way, our 3 over x, they tell us, they have to tell us, they tell us that h is 0.1. This is an arbitrary choice, okay? They do this to make the homework easier. That's fine. And they said they want to have y of 0 is equal to 1. Okay, I'm sorry, nope, that's not the problem at all. They have y of 1 is equal to 2. Okay, so when x is 1, y is 2. All right, so let's go ahead and set this thing up. So we start off with an x, we start off with a y. We know that when x is equal to 1, y is equal to 2. All right, here's our little table that we're making. All right, probably should have used a ruler. Our function, our g of x, right, our g of xy is 3 over x. No y's needed. So numerically, this is 3 over 1, which is equal to 3. And then we have our delta x in here, right? Our h, that's 0.1. And we're going to multiply them together. So this is just going to be, right? This is going to be g of xy times h. This is 0.3, right? And remember, our formula is y old plus that business right there, which is this thing here. Okay, this f of x old, y old times delta x, that's 0.3. So we're going to have our y old 2 plus 0.3, and we end up with a 2.3 here. Okay. Now, your book says, am I in frame for that? I sure am. Okay. Your book says we're going to report this to 3 decimal places. So I'm going to keep track of 4 of them, so we'll be accurate to 3. Okay. So next line, okay, we're going to have our new x. Well, we started at 1. What's the delta x? The delta x is 0.1. So our new x is going to be 1.1, right? Our new y, well, that was what this whole process was to do, was to figure out our new y. That's going to be 2.3, right? 2.3 here. And then we're going to continue on with our process here. So our g of xy, right, that's 3 over x. So that's going to be 3 over 1.1. So we'll go ahead and do that. That's 3, oops, let's turn this thing on. That's 3 over 1.1. And we end up with 2.7272. Okay, so that's 2.7272. Our delta x, our h, is still 0.1. So we're going to multiply this thing by 0.1, right? That just moves the decimal place over. If you have to do that in your calculator, that's fine. But we're going to end up with 0.2727. That's our g of xy times h. I should just put this over here because that's really where I set this thing up. Okay. And we're going to add our 2.3 plus 2.3000, right? Plus this guy right here. Okay, and I'm going to be, Well, I don't have to be that lazy. I can go ahead and do that. That's going to be 2.5727. Okay, just adding this to this. All right. So that's our new y. So we go to repeat the process here. Okay. So we're going to go ahead and increment our x. We have 1.1. Our delta x, right, is 0.1. So we're going to have a 1.2 here. Right. Our new y is 2.5727. Okay, and then we're going to continue up. So we have to do this 3 over x, 3 over 1.2, 3 over 1.2. This is horrible. All right, so we're going to end up with, let's go ahead and have a look at this. This is going to be 3 over 1.2. We're going to write that down to 4 decimal places. Thankfully, this one was nice, right? This is 2.5000. Our h, right, that is always constant when they set that up at the beginning of the problem. That's it. It's 0.1, okay? And we're going to go ahead and multiply that. So we're going to end up with a 0.2500, all right? And we're going to go ahead and add this to our previous y, or add it to our previous y. So we're going to have a 2.5727 plus 0.25. You can put the zeros in or not, it doesn't matter. Okay, and we end up with 2.8227. Okay, 2.8227. I am still in frame here. Okay, we're good. Okay, that's our new y. All right, that's our new y. So we're going to increment our x one more time. So adding 0.1 to it, we're going to have 1.3, right? We added 0.1, h was 0.1. And our new y here, this is going to be 2.8227. So what this is saying is when x is 1.3, y is 2.8227. Okay, so we have to do this one more time because they said you're finished with the problem when it's x of 1.4. Okay, and this is exactly the kind of question I would ask you to demonstrate for me on a quiz. Please, having access with the formula here, I'm not going to make you you don't have to memorize this. It's nice if you can kind of recreate it. It's not too bad, but it's not something I would ask you to do in this particular class. Okay, so you would have this. You just have to be able to put this table together and show me how you can get through it. Okay, and you can use, if you find different YouTubers, you find different methods. Maybe you have a more accurate table or a table that works better for you. By all means, okay, you can use that. So this is going to be 3 over 1.3. Okay, so we're going to go ahead. Let's have a look at what that is. So that's 3 divided by 1.3. Okay, and we ended up with, right, 2.30769 and some change here. So we're going to write this down. This is 2.307. Let's go with 7 here because we'll round up to that 4th decimal place. All right. Again, h is 0.1. We're just going to leave that in. Multiply the two of them together. So we just move the decimal point. That's 0.2307 or 08 rather, because we're rounding to 4 decimal places. And then we're going to go ahead and take our previous y plus this new step that we found. Okay, so we have the previous y plus the new step. So that's going to be 2.8227 plus this 4-digit number here, 0.2308. And we end up with 3.0535. Okay, so if I kept going with this, just to demonstrate this point here, we have x is 1.3 plus our delta x, 1.4. Our y is now the previous thing that we just found. Sorry about that. I'll let that get out of frame. So we have our previous y. So we're going to end up with 3.0535. That's what we had here. Okay, that's my new y. So what I was saying before, when x is equal to 1.4, y is equal to 3.0535. This is what they asked us to find in the textbook. Okay, so that's our answer. We're done at this point. You don't need to carry this through one more time. Okay, So this method gets better if your h's get to be smaller, okay? There's more advanced techniques that have you refine the slope estimate that you have, but you get to learn about those in a differential equations class or numerical methods class. We aren't going to worry about those. This is the basic idea. All of the methods pretty much follow something similar to this anyway. And yeah, that's what we have. So we have x is equal to 1.4, y is equal to, this is our function value. Okay. Now, how close did we get? Okay, that's what I want to know. How close did we get? This is not a terrible problem. We can solve this problem analytically and get the actual answer. Okay, so let's go ahead and do that. Oops. Let's see here. Pull up a good piece of paper for us. Talk about organizing yourself before you start giving a lecture here. All right, so we were starting off with dy by dx is equal to 3 over x. Now, I noticed a lot of you guys in the assignment that I gave, you went through and you did this with linear methods. That's fine, okay? So technically you could do this as dy by dx plus 0 times y is equal to 3 over x, and you could use an integration factor and solve it. But kind of like integrals, you kind of look at this thing and say, well, is it separable? Oh, it's separable. I don't have to do anything harder. Let's just go with the fact that it's separable. So we have dy is equal to 3 over x dx, all right? And then I could just integrate both sides, okay? We also know that y of 1 is equal to 2, all right? We know that. They told us this in the problem. So go ahead and integrate both sides here. We can't move the x outside. We can move the 3 outside if you would like. So we could have integral of dy is equal to 3 integral of 1 over x dx. Since we're dealing with the positive side, when I go ahead and integrate this, this is going to be 3 times ln of absolute value of x. But since we're talking about when x is equal to 1, we don't have to worry about the fact that we have negative values here. We don't have negative values, plus c. Y is already explicitly solved for. That's always nice. So we end up with, so we're going to go ahead and evaluate at x equals 1 and y equals 2. Am I in frame for that? No, I am not. Okay, so we're going to go ahead and evaluate x equals 1, y equals 2. So let's plug that in. Okay, so we have y is equal to 2. That's equal to 3 times the natural log of 1 plus c. Now, the natural log of 1 you shouldn't need a calculator for, right? That's 0. Is that right? Okay. And once we get that, we just get that c is equal to 2. Oh, that's lovely. Okay. So my function value here, right, y is equal to 3 times natural log. I'm not going to put the absolute values in because we really don't need them. We're dealing with positive stuff here. And plus 2 for my c. Okay, so there we go. They wanted to know when x was 1.4, what's y equal to? Okay, what's y equal to? So let's go ahead and plug that into the calculator here. Okay, so we're going to go ahead and say 3 times, am I in screen here? Sort of. 3 times natural log of 1.4, okay, close your parentheses because that actually matters, plus 2. And let's see what we get. So this is the actual value of our function here, right? Again, I'm just going to write this down. This is 3.009. We went to 3 decimal places in the book, so that's what we're going to go with, okay? 3.009. Great. Now, since you guys are mostly biology and chemistry majors, you've done labs, you've done experiments, so of course we have to have more fun by figuring out what was the percent error, right, from my experimental value. Recall my numerical value, my experimental value was the 3.05. I'm going to go ahead and round that number to 3 decimal places. That was 3.0535. We're going to go with 3.054. Okay, so we rounded this to our third decimal place as the book instructed us to do. Okay, the y actual value, right? The actual value, or the theoretical value, is the 3.009. Okay, so recall your percent error, right, is equal to 100 times, and we're going to use absolute values here. I just want you to disregard the negative sign, right? And that's going to be 3.009 minus 3.054, all divided by, right, 3.054. So it's oops, nope, it's not that. It's 3.009 here. Okay, it is going to be experimental, well, actual minus experimental divided by actual. The actual goes on the bottom. This, because of the absolute values, it doesn't really matter which order you put these in. Okay, and we're going to go ahead and sort that out. So again, we're going to go ahead and say this is 100 times parentheses, right? Because we have my parentheses here. And that's going to be 3.009 minus 3.054. Was that it? 0.054, it sure was. And parentheses divided by 3.009. That was my actual value. Go ahead and hit enter. And this is a percent error. Now, I'm not going to look at the negative sign here, right, because we have absolute values. So my value here is, this is 1.4955. And some change, we're going to call this 1.50% error, okay? So when they ask you to say, hey, what's the error here? We just rounded this to, it's percent error. I think percent error has a tendency to be 2 decimal place numbers, so that's probably what you did in lab. So that's what we always did in lab, was we rounded the error to 2%, 2 decimal places. So we'll go with that. Okay, and that's how you do a problem like this. Okay, so we have you're going to do the numeric part, you're going to do the actual part if you can. The problem will say do the actual part, and when they say compare, what I mean by compare is tell me what the percent error is. Okay, and again, if you asked me on a quiz, hey, what's the formula for percent error? I would just tell you. I have a feeling that all of you know anyway, but maybe in a quiz, it's not a formula that you have at the ready, so maybe you get nervous and you forget, whatever. But I wouldn't make a big deal about this. I would just tell you what the formula is. So if you're looking this up as you're doing it, that's fine. It's an easy enough formula that if you had to remember it, I know you could, but not that important. Okay, so you guys try one. I'll put up a worksheet for you. Tell me if this format works. If it doesn't, I'll find something else, and we'll go from there. Okay, good luck.